this question, a random variable y, which is defined as integration over minus infinity to infinity w of t into phi of t dt, where phi of t is given as 1 for the range 5 to 7 and 0 otherwise, where phi of t is a deterministic signal and w of t is a real wide Gaussian noise process with two-sided power spectral density SW of f as 3 watt per hertz. So W is a random process and we have been asked to find the variance of y. A detailed explanation for the concepts involved in this question and we found from the NPTEL course Principle of Digital Communication lecture 30. The concepts involved in this question are: mean of a random process can be found out from its power spectral density as E of x equals to root over integration from 0 minus to 0 plus Sx of f df, because we know that mean is the measure of the DC component of a signal. So hence we integrate from 0 minus to 0 plus for the power spectral density. Another theorem is the Rayleigh's energy theorem, which relates the energy in the frequency domain to be equal to the energy in the time domain. Next we will move on to the solution. Given y equals to integration minus infinity to infinity w of t phi of t dt, and phi of t is a finite duration signal lasting from 5 to 7 as 1 and 0 otherwise, so we can rewrite y as integration from 5 to 7 w of t dt. Now the power spectral density of W is given as 3 watt per hertz for all f. So we don't have any impulses at 0. According to the formula, mean of W equals to root of integration 0 minus to 0 plus SW of f df. Since there are no impulses at 0, so this area is 0. So mean of W is 0. So W is a zero mean random process. Hence the mean of y comes out to be as mean of integration 5 to 7 W of t dt. Since mean and integration are linear operations, we can write 5 to 7 mean of W dt, and this is 0. So y is also a zero mean random process. Now the variance of y is given as E of y square minus E of y whole square. So this term is 0. So variance of y is E of y square. E of y square is given as, now E of y square is also the power of the random process y and is given as integration from minus infinity to infinity sy of f df, and we can rewrite sy of s as integration from minus infinity to infinity sw of f into magnitude of phi of f whole square df in frequency domain, and we can rewrite this as minus infinity to infinity 3 into integration phi of f whole square df. So we can take 3 out of the integration and write it as minus infinity to infinity magnitude of phi of f df. Now as we have seen, using Rayleigh's energy theorem, we can write this as integration from minus infinity to infinity magnitude of phi of t whole square dt. Now phi of t is already known to us, so we can write this is 3 into integration from 5 to 7 1 square dt. So we can write this as 3 into 7 minus 5, and this comes out to be as 6. So the variance of y is equals to E of y square equals to 6. So the answer for this question is 6.